So here is the question. A lens held directly above a coin placed on a table forms an image of the coin. So after the lens is moved vertically a distance equal to its focal length, it forms another image of the coin equal in size to the previous image. So if the diameter of the coin is 2 centimeter, what is the diameter of the image? So first of all, if we read the question, it's mentioned that the lens is held directly above a coin. So what kind of lens is this? Is it a concave lens? It is a convex lens? We are not sure. So first of all, we have to determine what kind of lens it is. And then the second very interesting information is, after the lens is moved vertically a distance equal to its focal length, it forms another image of the coin which is equal in size to the previous image. So this is the thing that we have to use. The size of the image in two cases are equal. So another image of the coin equal in size to the previous image. So first of all, let's identify what kind of lens it could be. So in concave lens, we see if we have an object here and if we draw the ray diagram, we get the image somewhere here. And the image is always virtual and it is erect and diminished. So basically, if we move the lens now, suppose we move the lens towards this side, so we will definitely get a different value or different length of the image. And since every time the image will be virtual and towards the left, so for no two different positions of the lens can we get the same size. So basically concave lens is out of scope in this question. So let's analyze the convex lens now. So for convex lens, if we have an object here, we know, and suppose the object is far from f. So we will get a real image, real and inverted image somewhere here on the other side of the lens. And we also know that when the object is at infinity, basically we get a point image, and as we are moving towards the lens, the size of the image increases. So when can the size of the images will be equal? So this is only possible when one of the image is virtual, because when the object comes under or between f and the optical center, then the image is erect and virtual. So in that case, the size of the image might match with the size of the image in the previous case. So let's understand the situation first. So this might be our case. First of all, when the image is virtual, so the object is between f and the optical center O. So if we draw the image, we will get something like this. So for the object we get a image which is virtual and which is erect and it has some magnification. Now when the lens is moved away from the coin, because now we have to get a, basically in the question it's not given whether we have moved it away from the coin or towards the coin, but now since this is the case where we are taking the object between f and o and the image is virtual, so next case image has to be real, then only the magnification or basically at least the magnitude will match. So that means we must have moved the lens away from the object by a distance f. So the next scenario would be, it was mentioned that it forms another image of the coin equal in size to the previous image. It's not mentioned whether they are erect or inverted. It's just mentioned they are equal in size. So one of the image has to be erect, other has to be inverted, then only this is possible, and the lens has to be a convex lens. Now comes the part where we solve this problem. Now let's write a general case of the magnification and we will just compare the magnification. So in general we have the equation 1 by v minus 1 by u is equal to 1 by f for the lens, and let's calculate v in terms of u. So 1 by v is equal to 1 by f plus 1 by u. 1 by v is equal to uf, u plus f, and since we know magnification is equal to v by u, so we get magnification is equal to uf by u plus f. This is v divided by u. So magnification is f by u plus f. So this is the magnification. Now we will use this for two different cases. Now see, in the first case, if you see here, suppose the object distance is x from the pole. Now in this case the lens basically was moved by a distance f. So if the lens was moved by a distance f, this total distance of object from the lens will become x plus f. So we will use the formula of magnification, this formula, for these two cases, and here the magnification has to be positive because the image is erect, and here the magnification will be negative. So while comparing, we have to just compare the magnitudes because the sizes were equal. So first of all, for case 1, let's see what is the magnification. For case 1, so this is the case 1 and let's say this is the case 2. So for case 1, magnification m would be f divided by, so u is basically minus x plus f. So this is the magnification, and we know here m will be greater than 0 because x is less than f. So we can see this is greater than 0. For case 2, if you see, here the magnification will be f divided by, now the u here is minus of x plus f. So here we will write, instead of u we will have minus of x plus f plus f. So this is the magnification in the second case. And here we know, see, if you see, this thing obviously is greater than f, so we will get a negative value, m is less than 0. Now on comparing the magnitudes of m, we know we have to compare the magnitude, and this m is positive and this m is negative. So we will put a minus sign here in the second part to make it positive, and then we can compare. So we can write f divided by minus x plus f is equal to minus of f divided by minus x minus f plus f. Now we are using minus here because we know this quantity is negative. So we are adding a minus to make it positive, and this quantity was positive. That means we are just comparing the magnitudes. So we get the result as f divided by minus x plus f is equal to minus f divided by minus x. Now f gets cancelled, so we have minus x is equal to x minus f, or basically x is equal to f divided by 2. So we have the value of x as f divided by 2. Now we can use the magnification and we can get our magnification and then the size of the image. So magnification is f divided by u plus f. So u can be written as, you can take the any case, either 1 or 2, magnification is same. So let's the case 1, u is minus x basically. So u is minus x plus f, and the value of x we have already got as f by 2. So here we get magnification is equal to f divided by minus f by 2 plus f. So this is equal to 2. So this is our magnification 2. That means the size of the image or diameter of the image of coin will be 2 times the diameter of the object. That means the diameter of the coin, which is 2 centimeter. So our answer will be 4 centimeter.